friends, after discussing the middle ear and the middle ear cleft, let us go to the third part of the ear, inner ear. Now, inner ear is also called labyrinth. Labyrinth. So when we see the word labyrinthitis, labyrinthine fistula, think of inner ear. Okay. Now, as far as your inner ear is concerned, this is what the inner ear look like. Okay. So inner ear, always whenever we look at any anatomy text or ENT text, we see inner ear is like this actually. Basically, inner ear has got two parts. Let us understand them. What are two parts of inner ear? The two parts of inner ear are, one part is membranous labyrinth. Membranous labyrinth. Membranous labyrinth is the actual fleshy inner ear, which you imagine as inner ear, the soft part, the real part, actual inner ear. Actual inner ear. Now, number two is bony labyrinth. Bony labyrinth is the bony cover of inner ear. Bony cover of the inner ear, and this is of the same shape. If cochlea is like this, a bony cover is also around that cochlea of the same shape. Now, which bone it is? Think about it. Inner ear is lying in which part of the temporal bone? Yes, the bony labyrinth is formed by petrous part of temporal bone. Bony labyrinth is formed by which bone? Petrous part of temporal bone. And guys, please make a note that this is the hardest bone of the body. If you ever get a question in anatomy, which is the hardest bone of body, please mark it is the petrous part of temporal bone. Now, petrous part of temporal bone is the hardest bone of the body. Okay. The bony labyrinth is made by which bone? Temporal bone, yes. But which part of temporal bone? Petrous part of temporal bone. And my concept is the external ear and middle ear are up to tympanic part of the temporal bone. But inner ear is situated within the petrous part of temporal bone, the hardest bone of the body. Now, let's go further. Now, see over here. Now, imagine this is the bony cover, the yellow bony cover. Within this, we have the actual inner ear. Now, imagine this is a bony cover, okay? Now, within this is the actual cochlea. Can you imagine? Fine. This red thing is the membranous labyrinth. Then this is the utricle saccule. And then we have got the three canals, like this. Okay, fine. Am I clear? Fine. So, now everybody should be clear. The red part in the picture is the membranous labyrinth, the actual inner ear. And the yellow part around that is the bony labyrinth, the bony cover of the inner ear, and this is of the same shape. Okay, let's go further now. This is your temporal bone in front of you. Where is the temporal bone? I hope you remember this is the temporal bone of both sides. Okay, and by now we know that inner ear is lying over here. Inner ear is lying over here. This is your cochlea, utricle saccule, and three canals. And this is covered by a bony cover of the same shape. This black bony cover is called bony labyrinth, which is made by the petrous part of temporal bone. The red one is the real inner ear, which is called the membranous labyrinth. Okay, fine. Let us discuss now the three parts of inner ear. Actually, whenever we see at the inner ear, please see, imagine this is the division lines. Now, this is your cochlea, this is your saccule, this is your utricle area, and these three are semicircular canal. Okay, am I clear about the three parts of inner ear? Cochlea, neighbor of cochlea is saccule, then utricle and semicircular canals. Okay, let's elaborate this concept further. Allow me to again draw the lines. Okay, fine. Now let me write down the part name. Now this part is called cochlea. The neighbor of cochlea is saccule. Then come U is utricle. Utricle and saccule make one part. And then is semicircular canals. 3 semicircular canal. Okay. Now, let us write down what is the function of the each part. F1 a function. Of course, cochlea is meant for hearing. Rest everything is for balance. Utricle saccule are meant for linear balance. Linear balance. Standing upright is linear balance. Canals are meant for angular balance. Look at the canals. They are attached at 3 different angles. So just to remember, they control angular balance. When I say angular balance, you see when I look back like this, when I rotate my head, this is maintaining my gaze also, my balance also. This is angular balance. Okay, fine. Now, the third line. The third line is sensory end organ, means receptor. Every sensation is carried through a receptor. For the hearing, cochlea has organ of Corti. The sensory end organ of cochlea is organ of Corti. For utricle saccule, we have got macula. Macula. Macula is the sensory end organ of utricle and saccule. And number 3, canals have got crista. Crista. Okay. Look at this diagram, beta. The first red line indicates the part of the inner ear. The second line, blue line, indicates the function of that part. And third, purple line indicates the sensory end organ of that part. Allow me to summarize. Cochlea has organ of Corti for hearing. Utricle and saccule have got macula for the linear balance. And semicircular canals have got the crista for angular balance. Okay, fine. I hope this basic concept is clear. Everybody should be clear about macula, crista, organ of Corti. But organ of Corti. Cochlea has organ of Corti for hearing. Utricle saccule have got macula for linear balance. And semicircular canals have got crista for angular balance. In one inner ear, you have got one organ of Corti, 2 macula, 1 in utricle, 1 in saccule, and 3 crista, 1 in every canal. Okay, so that's the meaning of this. Let's go further. Let us discuss the fluids of inner ear. Now, inner ear has got 2 fluids. Number 1 is endolymph and number 2 is perilymph. Perilymph. So basically, inner ear has got 2 fluids, endolymph, perilymph. Can you see this picture? Can you see this purple fluid? The purple fluid represents the endolymph and the yellow fluid represents the perilymph. Am I clear? So, in a very simple way, inner ear is filled with endolymph and surrounded by perilymph. Peri means surround, na? Inner ear is filled with endolymph surrounded by perilymph. Am I clear? Fine. Now, let us discuss these fluids individually now. Number 1, endolymph. Endolymph, it is produced by stria vascularis of cochlea. Stria vascularis of cochlea. And it is absorbed by endolymphatic sac, which is a part of inner ear only. Endolymphatic sac is a part of inner ear only. Endolymph is own fluid of inner ear. It is produced by inner ear, absorbed by inner ear. Endolymph is produced by stria vascularis of cochlea, absorbed by endolymphatic sac. Now, clinical concept. Put an arrow. If this sac does not absorb the endolymph properly, if this sac does not absorb the endolymph properly, then what will happen? It will lead to a disease called Meniere's disease. It will lead to disease called Meniere's disease. Beta. Complete topic of Meniere's we'll discuss in the video, next videos. But what is the cause of Meniere? Basically, the endolymphatic sac is not absorbing the endolymph properly. Okay? And that will lead to a disease called Meniere's disease. Now, in Meniere's disease, what will happen? There will be gradual cochlear damage. Gradual cochlear damage due to high endolymphatic pressure. Gradual cochlear damage due to high endolymphatic pressure. Don't you think so? If endolymph start collecting in the inner ear too much, due to high endolymphatic pressure, there will be gradual cochlear damage due to high endolymphatic pressure. So what happens in the mean ears in the later stage? There is a gradual damage of the cochlea due to high endolymphatic pressure. Guys, can you think of any similar disease in ophthalmology where high intraocular pressure start damaging the optic nerve? Yes, it is glaucoma. Yes, glaucoma. So to summarize the concept, I can say mean ears is glaucoma of ear. So that you start making a clinical concept around what is the basic meaning of mean ears. So just imagine mean ears is glaucoma of the ear. So this is about the endolymph. Now let us now discuss the second fluid, perilymph. Inner ear is filled with endolymph surrounded by perilymph. Now endolymph is the own fluid of inner ear. It is produced by inner ear, absorbed by inner ear. But perilymph is a borrowed fluid, borrowed fluid from somewhere outside. Where do you borrow things, From your neighbors. From your neighbors. What is the neighbor of the inner ear? Look at me. External ear, middle ear, inner ear. What is next to inner ear? Brain. External ear, middle ear, inner ear. What is next to inner ear? Is brain. Brain. So we borrow things from our neighbors, So what is the neighbor having? What is the brain covered by? CSF. So inner ear asks for CSF to cover it. The same CSF here is called perilymph. Perilymph is not a new fluid, it is CSF only. It is borrowed fluid from the brain actually. Okay, fine. So now let's discuss perilymph. Perilymph is CSF only. Very simple concept. Perilymph is CSF only. As CSF covers the brain, the same CSF covers the inner ear. There that CSF is called perilymph. Perilymph. Okay, fine. Now, see over here. This is your inner ear. Cochlea, utricle, saccule and canals. Now, what lies over here is brain. Brain. And brain is covered by CSF. Okay. The same CSF has to reach over here to cover the inner ear. Okay, fine. But I think you would agree with me. You need a channel to connect the CSF of the brain to the perilymph of the inner ear. Don't you think so? You need a bony channel because look at this discriminator. Look at this thing. Now CSF has to reach over there and it has to surround the inner ear and the same CSF will be called the perilymph. Now this is actually your perilymph. Am I clear? Same CSF is called perilymph. But don't you think so? You need a bony channel to connect the CSF with the perilymph. Now this bony channel, look at the purple arrow. This bony channel is important. It's a multiple choice question. Now this bony channel is called aqueduct of cochlea. So aqueduct of cochlea connects CSF of the brain to the perilymph of the inner ear. Okay. Now let's write down. Now where is your perilymph, my dear friends? Perilymph is in your inner ear. Inner ear. Okay. Now where is your CSF? CSF is in the subarachnoid space of brain. Subarachnoid space of brain. Now perilymph and CSF are connected with a bony channel which enters the temporal bone to reach the inner ear, and this bony channel is called aqueduct of cochlea. Do you understand? Such a important question of anatomy. Aqueduct of cochlea connects CSF to perilymph. Guys, don't you think this connection can be dangerous? Your brain is your neighbor, and if something happened wrong with the neighbor, it affects you also. So brain can get meningitis. The same infection, look at the screen, the same infection, this brain got meningitis. Okay, the same bacteria can travel through aqueduct of cochlea and can reach the inner ear also. And they can damage the inner ear. That is why meningitis has one complication which is called post-meningitis deafness. Can you understand? But such an important concept. Oh, inner ear is neighbor to brain and they're connected by a channel called aqueduct of cochlea. So meningitis infection can reach the inner ear, can damage the inner ear. That is why few children who are suffering from meningitis, they can develop post-meningitis deafness. Okay? Now, write down this pathway is the cause of post-meningitis deafness. Post-meningitis deafness. This pathway is the cause of post-meningitis deafness. Okay, fine. Now, let's go further now. Let us discuss about the ionic composition of the endolymph and perilymph, and let me make it simple for you. This is just like intracellular and extracellular fluid. Okay, so you remember that endolymph is like intracellular fluid. Can you tell me? Endolymph will have what? Yes, high what? High potassium, low sodium. But perilymph has got high sodium, low potassium. Okay, just like intracellular, extracellular fluid, inside the inner ear, we have got high potassium, low sodium. In the perilymph, we have got high sodium, low potassium. Let us now go further. Now, let us discuss each part of inner ear one by one. The first part is cochlea. Look at the cochlea. Okay. Now, cochlea has 2 3/4 turns. Cochlea has 2 3/4 turns. Okay. Can you see? This is like a snail shell kind of thing. Okay. 2 3/4 turns. Now, let us label it. Now this is called basal turn of cochlea. Basal turn of cochlea. This is called apex of cochlea. Apex of cochlea. The apex is also called as helicotrema. Helicotrema. Okay. The basal turn of cochlea and the apex is also called helicotrema. Now, each part of cochlea is responsible for hearing a specific frequency sound. Okay. Now, please see, the basal turn senses high frequency sounds, but apex senses low frequency sounds. Okay. The dull sounds, b, the, r, these sounds are heard towards the apex of cochlea. But the sharp sound, high frequency sound like ma, na, these kind of sound are heard in the basal turn of cochlea. If I can just tell you roughly, you have got 250 hertz heard over here, okay? Then 500 may be here, then 1000 is over here, then 2000 is over here, 4000 is over here, 6000 over here, 8000 over here, and so on. So, towards the basal turn, you hear the high frequency sounds. Towards the apex, you hear the low frequency sounds. Okay. Now, it means that if some disease will damage the basal turn of cochlea, the patient will be having high frequency hearing loss. If a disease will damage the apex of the cochlea, that patient will be having low frequency hearing loss. So that's the meaning of this, beta. Okay, fine. Now let us discuss the cut section of cochlea, beta. By now, you will be knowing that cochlea is a fleshy tube in a bony tube, beta. You understand, this red thing is a fleshy tube, the yellow thing is the bony tube, beta. The red tube is the fleshy tube, the membranous cochlea, and the yellow cover is the bony cover of the cochlea, beta. So cochlea can be imagined as a fleshy tube in a bony tube. Now the red tube, the fleshy tube, is filled with endolymph, and the yellow tube, the bony tube, is filled with the perilymph, beta. Okay. So can you imagine cochlea like this, beta? It's a small water pipe in a big water pipe. The small water pipe, the actual red cochlea, is filled with the endolymph. The big water pipe is filled with the perilymph. The big water pipe represents the bony cover, beta. Let us do one thing. It's a coiled tube. Look at my hand. It's a coiled tube like that. Let us uncoil it, beta. Unroll it, beta. Let us make the cochlea a straight tube. Unroll it and make it a straight tube. And then cut it in between. It's a small water pipe and a big water pipe. If I cut it like this and show towards you, you will see three compartments. One central compartment, the red one, the actual cochlea, and one empty space above, one empty space below. Okay, those two empty spaces are perilymphatic spaces. Let us draw the cut section of cochlea. Every draw diagram with me. Take a rough page, draw. This is the big water pipe, the bony cover of the cochlea. Now, everyone, this is the actual cochlea, the small water pipe, the red pipe, the membranous cochlea. Okay. Now, let us label them. Now, this part is called scala vestibuli. S means scala. The vestibuli. The middle part is called scala media. Middle part scala media. And the lowest part is called scala tympani. Scala vestibuli, scala media, scala tympani. Let us clear at the outset only. This is perilymph, and this is endolymph. Am I clear? Endolymph is produced by stria vascularis of the cochlea. There is a vascular layer over here in the cochlea that produces the endolymph. What is this? Stria vascularis of cochlea. I hope you remember, endolymph is produced by stria vascularis of cochlea. And it also keep secreting potassium ions. That is why potassium is very high inside the inner ear. And that generates plus 80 millivolt potential because stria vascularis keeps secreting the potassium cation in the endolymphatic fluid continuously. That is why inside the cochlea always is a positive potential, positive 80 millivolt. Okay. Let us label the membranes better. Now, this membrane is called Reisner's membrane. Very popular question. Reisner membrane separate what and what? Reisner membrane separate scala vestibuli from scala media. Then comes this membrane. This is called basilar membrane. Basilar membrane separates scala media from scala tympani. Am I clear? Scala media and scala tympani. This is your organ of Corti. I hope you know organ of Corti is the sensory end organ of cochlea. Organ of Corti. And organ of Corti are covered by another membrane. Organ of Corti are covered by another membrane, and that is called tectorial membrane. That is called tectorial membrane. Organ of Corti is covered by tectorial membrane. Now, organ of Corti has got hair cell. Draw hair over there. Hair cell. Okay, fine. Am I clear? Let us revise. Reisner's membrane separates scala vestibuli from scala media. The basilar membrane separates the scala media from scala tympani. Organ of Corti are lying on basilar membrane, and organ of Corti are covered by tectorial membrane. Okay, fine. Let us write few lines about organ of Corti. Now, organ of Corti, which is the sensory end organ of cochlea, organ of Corti lies on basilar membrane and covered by tectorial membrane. Am I clear? Organ of Corti, look at the diagram. Organ of Corti is lying on basilar membrane covered by tectorial membrane. Okay. Now, sound energy moves basilar membrane. I hope remember, stapes acts like a piston. Stapes acts like a piston. You know piston? Like this. This moves the fluids of the cochlea. Due to that, there is movement of the membranes of the cochlea. Particularly, sound energy moves which membrane? Basilar membrane. Because on top of that, we have got the organ of Corti. When basilar membrane moves, organ of Corti move and they get stimulated. Okay. The sound energy moves which membrane? Basilar membrane. And this stimulates organ of Corti. Sound energy moves basilar membrane and this movement of basilar membrane stimulates organ of corti, and that generates the electrical energy, and that electrical energy goes to the brain. Let me show you a video in which you will see the sound energy is moving basilar membrane. Just see this video. So guys, you saw in this video how sound energy is moving basilar membrane, and that is stimulating organ of corti, and that is producing the electrical energy which is going to the brain via 8th nerve. What is 8th nerve? Vestibulocochlear nerve. Okay. Now, this theory which explains the physiology of hearing is called travelling wave theory. Travelling wave theory. So, which theory explains the physiology of hearing? The answer is travelling wave theory, which was given by von Becquerel. So, this is travelling wave theory of von Becquerel. Just remember this name, travelling wave theory of von Becquerel. Von Becquerel. Okay, fine. Chalo. Let's go further now. Now, let's go to the neighbor of the cochlea, and cochlea's neighbor is saccule, and cochlea and saccule are interconnected via a channel called ductus reunions. Look at screen, beta. This is my cochlea, of course, and this is my saccule. And I know now from embryological discussion also that cochlea and saccule are neighbors, and they are connected through a channel, and that channel is called ductus reunions. Ductus reunions. My dear friends, even saccule is also connected to utricle, and utricle is connected to all three canals. Everything is interconnected. It's not only cochlea is connected to saccule. Everything is one system in continuity. If endolymph is in cochlea, the same endolymph goes to the utricle, saccule, and to the canals also. So every system is interconnected, but ductus reunions is important because this is a connection between the hearing element and the balance element. Cochlea is the hearing element of the inner ear. From saccule starts the balance element, beta. Okay. So cochlea and saccule are connected through a channel called ductus reunions, beta. Okay. Now let us start the second part of inner ear, utricle and saccule. The first part was cochlea. The second part is utricle and saccule. It's also called as vestibule, beta. Whenever you read the word vestibular, think of balance system, beta. Vestibular, beta. Balance part of the ear, beta. Also called otolithic organ. This is a star question. You should know everything about otolith. Otolith is a very popular source of question, in clinical story also. Otolithic organs. Let's understand utricle and saccule. Now, what is the function of utricle and saccule? And I'm sure you remember they control our linear balance. Standing upright is linear balance. There are two linears. This is vertical linear and horizontal linear. Now, which controls what? Now, utricle controls the horizontal linear balance, but saccule controls the vertical linear balance. Am I clear? The work is distributed. Roughly we say utricle, saccule control linear balance, but we know there are two linears. Vertical linear, horizontal linear. The utricle controls the horizontal linear balance and saccule controls the vertical linear balance. Okay, now let's go further. What is the sensory end organ of utricle and saccule? Remember, macula. Macula. I hope remember, utricle, saccule have got a macula for linear balance. So macula is the sensory end organ of utricle and saccule. Please look at screen, beta. This is your saccule. This is your utricle. There is one macula here and second macula here, beta. Only two macula. Okay, fine. They have shown it open also, and they have shown within that one sensory end organ over there. Okay. Now, let us see over here. Now, everybody knows this is saccule and this is utricle. Now, there is one macula here and one macula here. Am I clear? Now, the macula is covered by a gelatinous layer. Macula is covered by gelatinous layer. Am I clear? Macula is covered by this yellow gelatinous layer. In this gelatinous layer, we have certain calcium carbonate crystals. Okay, these calcium carbonate crystals are called otoconia or otolith. Very popular question, otoconia or otolith. Where are they found? They are found in the gelatinous layer of macula. Once again, beta, saccule and utricle have got sensory end organ, the red in color, macula. It's covered by a yellow gelatinous layer which has got calcium carbonate crystals, and these calcium carbonate crystals are called otoconia or otolith. Okay, now otoconia or otolith are calcium carbonate crystals in the gelatinous layer of macula. This is normal histology of the macula. But sometimes these otoconia, they turn free from that gelatinous layer, they come out, they fall in the endolymph, and then they start floating in the endolymph. And sometimes while floating in the endolymph, they enter these semicircular canals. Look at screen, everyone. Now what will happen? See everybody, this is your otoconia floating over here. Can you see the yellow spots? By chance, these otoconia enter the semicircular canals. And you know, they will start irritating the canal. Particularly when you move your head, they irritate your canal. And you know, canals are meant for angular balance. If canals are unduly irritated, the canals start creating angular imbalance. What is angular imbalance in layman term called? Vertigo. What is vertigo? Angular imbalance. Okay? You feel, you know, everything is moving like that. The sensation of illusion of movement like that. Okay? So, this is a disease. Okay? What is a disease? Now, if otoconia turn free, they were supposed to be impregnated in the gelatinous layer of macula, but if they turn free and they reach semicircular canals, it will lead to a disease called BPPV, benign paroxysmal positional vertigo. If otoconia turn free and reach semicircular canal, it will lead to a disease called BPPV. BPPV, very 5-star topic, BPPV, very important topic, 5-star topic, BPPV. Let us discuss BPPV in more detail. What is full form of BPPV? Let us start BPPV now. Benign means nothing to worry with. It's not a disease which will kill you. Paroxysmal means suddenly. Positional means on changing head position. Vertigo means, doctor, I feel dizzy. Doctor, when I change my posture of the body or head, I feel dizzy for few seconds. Benign, paroxysmal, positional, vertigo. Am I clear? Now, this is a very important topic, beta. First of all. Now, what is the cause of BPPV? The cause of BPPV is displaced otoconia. From utricle saccule, they reach semicircular canal. Okay, from utricle saccule, they accidentally reach to semicircular canal. Very common disorder. BPPV, it is the most common cause of peripheral vertigo. Can you imagine? Most common cause of peripheral vertigo. When I say peripheral vertigo, means due to ear problem. One is brain problem vertigo, central vertigo. But the most common cause of peripheral vertigo is BPPV. Okay, BPPV. Now, it is more common in females. The BPPV as a disease is more common in females. It's a very common problem in the practice. Okay, now let's go further. As I told you, the BPPV causes displaced otoconia and they reach from utricle saccule to semicircular canal. Now, the question asked in the exam is, there are 3 canals. Now, the ask is, which is the most commonly involved canal in BPPV? Okay. Now, please see, the answer is posterior semicircular canal. Posterior semicircular canal. Please see on the screen. This is your utricle saccule otoconia and they reach the posterior semicircular canal. This is which canal? Posterior SCC. So most commonly, otoconia migrate to which canal? Posterior canal. So otoconia migrate to canal, agreed. But which canal most commonly involved is posterior semicircular canal. Okay. Now, let us discuss the clinical profile of the BPPV. The symptom is vertigo for few seconds only. The main thing is vertigo is for few seconds only on changing head position. On changing head position. Vertigo for few seconds only on changing head position. Doctor, when I'm lying down, I take a turn on the right side or left side, I feel dizzy for few seconds. Okay. Now patient knows, always talk to the patient first. Which side you get the vertigo? The patient will tell you, sir. Some patients say, doctor, I take a turn on the right side, only then I feel vertigo. It's a right BPPV. The other patient will say, doctor, when I take the turn on the left side, only then I get the vertigo. It's left BPPV. Always talk to the patient. Absolute mandatory requirement to be a good clinician is talk to the patient first. Taking history and examination. So it's right BPPV or left BPPV, that will come from the patient history. So the common thing is, patient says, the doctor, when I change the position of my head, I feel vertigo. When I'm sitting down, I lie and suddenly everything starts rotating. But for few seconds. The important point is, there is no other symptom in BPPV. No hearing loss, no tinnitus, nothing. There is no other symptom in BPPV. Please do remember, in BPPV, V is vertigo. It's only vertigo. And that too also for few seconds. Otherwise, there is no other symptom of any other type in BPPV. Now, after taking history, you know right side BPPV or left side BPPV, you have to confirm it is BPPV. Now, what is the diagnostic test of BPPV? The answer is Dix-Hallpike maneuver. Dix-Hallpike maneuver is the diagnostic test of BPPV. It's a test of BPPV. Okay, fine. How we do it? Now, this can be a visual question. Visual question. Dix-Hallpike maneuver has two positions of the patient. The first position is of the sitting, and then you hold the head of the patient and suddenly bring his head down. Second position. So in Dix-Hallpike maneuver question, visual question, you will have two positions of the patient. One, the doctor is holding the head of the patient in sitting position, and in the second picture, the doctor will be bringing the head suddenly down, and at this moment, patient will have got vertigo and the eyes will show nystagmus. Look in the eye of the patient. When you bring the head suddenly down, if this disease is positive, patient will be showing nystagmus. Nystagmus, beta. Okay, fine. See the nystagmus, beta. So there will be vertigo, yes, and there will be nystagmus also. Now this nystagmus will be rotatory and geotropic. Rotatory and geotropic means the eyes move like this towards the ground, beta. Ground. Head is like this and you brought the head suddenly down, the eyes beat towards the ground. It's called rotatory and geotropic nystagmus. Okay, fine. So basically, the eyes will move towards the ground side. The eyes will beat towards the ground side. Geotropic. So Dix-Hallpike maneuver is the diagnostic test of BPPV. It has got two positions. Okay, fine. Now, what is the treatment of BPPV? Another maneuver. The treatment is Apley's maneuver. Guys, Dix-Hallpike is the test. Apley's maneuver is the treatment. What we do in the Apley's maneuver? Let me show you. Now, this is Apley's maneuver. Now, Apley's maneuver is another visual question, but it has got 5 different positions. Number 1 position, make the patient sit down. Number 2 position, make the patient lie down. Then, number 3 position, Number 3 position is rotate the head of patient on the other side. Then number 4, ask the patient to take full turn of the body on that side. And then number 5, make the patient sit down again. From sitting to sitting, 5 position. First position sitting, last position sitting. The second position is lying down. Third position is turn the head. Fourth position is turn the body. And fifth, again sit down. Sitting, lying down, turn the head, turn the body, and then again sit up. So sitting 5 position is Apples maneuver. What you are trying to do by doing this, you are trying to send the otoconia back from where they came. You are trying to send the otoconia back from where they came. From where they came, utricle saccule, beta. You are trying to send the otoconia back to utricle saccule, and once they reach over there, they get dissolved, beta. Most of the cases, they get dissolved, beta. They get eliminated, okay? It's a miraculous therapy, beta. You're trying to send the otoconia back, beta, from where they came. That is why Apples maneuver is also called particle repositioning maneuver. Particle means otoconia, reposition means to send them back, beta. So that is why in some literature, some textbooks, Apples maneuver is also labeled as particle repositioning maneuver. What is particle? Otoconia. And what is repositioning? So send it back to utricle and saccule, beta. Okay? So this will be Apples maneuver, beta. Am I clear? Now, it's a very successful therapy, beta. Believe me. You know what? It's miracle. Patient will say suddenly. And BPPV is a very common problem in the population, beta. But if you do proper Apples, then immediately patient gets better, beta. Okay? But you have to learn it properly. It's not that, oh, you saw it, you did, and today only you go to house and your landlord says that I've got vertigo, and you say come here, and you make him lie down, sit up, and all that, and you know what, you bring the otoconia back from whatever was left also, beta. You can make the position worse also, beta. The landlord is going to kick you out of the house. You know what? Don't do that. So you have to learn it properly, beta. Okay? But once you learn it properly, it's a miraculous therapy. Now, just a quick question for a visual question. Identify this maneuver, beta. Can you tell me? Is it Dixolpike, Semont, or Apples? Yes, 2 positions, beta. Correct. This is Dixolpike maneuver, which is diagnostic test of BPPV. Okay, fine. Another question. Identify this maneuver. Is it Dixolpike, Apples, or Semont? The answer is yes, it is Apples maneuver, which is a treatment of BPPV. 5 position, Apples, 2 position, Dixolpike. Okay? Visual question possible.